Ben has to take his meds. Okay, so we're live, and I needed to make a video for this review anyway, so I decided to just do a YouTube live. Hi, Caroline. Caroline, can you just tell me, can you see this correctly, or is it backwards? Because I keep having problems with that. Does it look correct to you, or does it look backwards? I don't know where Caroline went. All right, I'm just going to go ahead and get started, and someone's going to tell me if the screen is reversed. So here we go. Number 1 says find the amplitude, period, and midline of the following function. So first thing I notice is that it looks like a sine function because it starts in the middle, and it goes from -2 to +2. So here's the midline at y = 0. The amplitude is from the midline to the maximum, so that's 2. And the hey, Smooch, do you have a highlighter? Mm-hmm. Can you get me a highlighter? That would be helpful. It's reversed. Jeez Louise. Caroline says it's not reversed. Wait, let's try this. Better?
I don't know if this works.
Lord, this is the reversing thing. Sorry, Lily was slow logging in. Miss Weiss, how am I now? Okay, so I clicked the reverse button in advance this time, and apparently it was not reversed. But this time I'm also using the USB cable because my phone battery is low. So I don't know. I guess the moral of the story is Lily always has to log in and check it. Okay, thank you for the highlighter. So we're looking for the period here. So I'm going to start here. I'm going to go to here. And so that makes a period of 4 pi. All right. Number 2, find the period of the function below. The easiest way to find a period is always starting when x = 0. So if I start where x = 0, I can trace one period to pi. So one period here is just pi. Now let's say you're a top-to-top person and you're going from top to top. This is pi over 2, which means this is pi over 4, which means this is 1 pi over 4, 2 pi over 4, 3 pi over 4. This is -pi over 4. So if you're a top-to-top person, you're going 3 pi over 4 minus -pi over 4, which becomes positive. 3 pi plus 1 pi is 4 pi. Divided by 4 is still pi. How does it look?
It's fine.
Okay, thank you, love. All right. Number 3, state the amplitude and period of the following function. All right, well, the amplitude, we want to be really careful here. This negative is not part of the amplitude. It is the reflection over the x-axis. So the amplitude is just 4. To find the period, I'm going to do 2 pi divided by pi over 3. Any interesting comments? Everyone's just saying hi to each other. It's like your group chat.
Yeah.
All right, so now I'm going to go 2 pi over 1 times the reciprocal, 3 divided by pi. The pi's cancel off. And the period is just 6. Number 4, describe the transformation to get the graph G starting from the graph F. So if I start here, that's what I sound like. If I start at cosine and I'm trying to get to G starting at F, I'm going right pi over 4 and up 1. Oh, it's multiple choice. That's funny. All right. These are the same. No, yeah, it's a 2. Never mind. It's not the same. Okay, cool. Match the graph to the right with the correct function. All right. Well, first of all, because it starts at a maximum, I know it's a cosine function. So goodbye. And because the amplitude is 4, 1, 2, 3, 4, I'm pretty sure it's letter C. But just to double check, here is one period. Period is pi over 2. And that's the same thing as 2 pi divided by b. And if I cross multiply, I would get b is 4, and there b is 4. Hooray.
Hooray.
Hooray. Page 2. You can see my beautiful tablecloth.
It's new.
It's water resistance.
And new.
It is new because,
See the highlighter from the paper.
You can't see the highlighter through the paper. It's okay. Write one sine and one cosine function for this graph. So the first thing I'm going to do is find the midline. This is 5. This looks like the midline. Yeah, that's definitely the midline. Midline is y equals 1.
But it's on the middle.
It's in the middle of this part.
Oh, that's
It's not like it's the middle up and down, not the middle side to side. 6th grader.
Oh, sorry.
Well, if we have any fraction work, we'll let you know. All right. The amplitude is 1, 2, 3, 4. Period. Let me get my highlighter. I'm going to count bottom to bottom because that's just the easiest thing to do. And we have a period of 2. So I'm going to make a note, which is 2 pi divided by b. Well, this one's pretty easy because I can tell that b is pi. Like, I don't have to cross multiply and divide. I know b is pi. So when I start to write this, I notice that when x equals 0, it's at the very bottom. So I'm going to write it as a reflected cosine function. So I'm going to go y equals -4 cosine. B is pi, so b pi x plus 1. Okay, so let's say I wanted to write it as regular cosine because I just like to pick this. This would have been helpful if I'd had like 6 colored pens, but I don't feel like getting them. So no, it's okay. So this is we'll say this is number 1.
There's only 4 people watching.
Well, that's depressing.
Yeah, you had 8.
I had 8. It's all right. Really, the purpose of this activity was to make the video. And
now you have 5. Never mind.
Thanks for the report. All right, so we'll call this number 2. So this would be like y equals 4. Well, Miss Wee's probably left because she knows how to do this.
We'll let another person join.
Plus 1. All right, so if I was writing it like a sine function, this is my third one. It's in the center on its way up. So I'm going to go y equals 4 sine pi. And then if this is 1, this must be a half. What are there funny comments? Are they inappropriate?
No.
Oh, Miss Weiss is still here. Plus 1. And then we'll do equation 4. And remember, you only need to do 2 of these. If it's on the center heading down. I feel like Miss Weiss's kids bathe way more often than you guys. They bathe like every night. If I can get your brother in the shower 2 or 3 times a week, it's just what? That's okay. I can explain, but maybe that's good. They see it a different way.
Well, then.
Yeah. Now I lost my spot. Oh, I was here. So that's 1.5. So 1.5. All right. So just pick your favorite sine and cosine function and call it a day. All right. Now I've got another one. 1 sine and 1 cosine function. So looks like I've got, I could average these. Like I know that, but sometimes I don't want to. Like I could do 1 plus 7 is 8 divided by 2 is 4. Like I could do that to find the midline. And from 4 to 7 is an amplitude of 3. It's got a period of pi over 2 equals 2. Okay, this is clearly not enough space. So I'm going to solve for b. I'm going to go pi over 2 equals 2 pi over b. And it's already a fraction, so let's cross multiply. We get b pi equals 4 pi. And then obviously the pi's cancel. B is 4. Again, I'm going to write this as a reflected cosine because it starts at the bottom. I'm going to say y equals -3 cosine 4x plus 4. I could also write this as a cosine starting up here, and that would be y equals 3 cosine 4x minus pi over 4 plus 4. I don't even want to know what you're doing. You're making faces at yourself. Can you see? Oh, in the reflection. All right, this is pi over 4. That would be pi over 8 because 1/2 of a 4th is an 1/8. So I could do y equals 3 sine 4 x minus pi over 8 plus 4. I don't feel like finding what point this is. If you really want to, I think it's 3 pi over 4. So, oh, we already did it. Might as well write it down. Negative 3 sine 4 x minus 3 pi.
That's a lot of work just for one problem.
Well, they just have to write 2 of them. They can pick their favorite 2.
Cool.
Okay. Number 8 says graph g of x equals negative 3 sine x plus 2.
Now you have 7 viewers.
That's okay. So I'm going to go up to 1, 2. I'm going to make a dotted line at my midline. Okay. Now I'm actually going to describe this first because I think it's easier. So I know it went up 2. It reflects over the x-axis. And it has a vertical, I can't spell vertical.
Neither can I.
What?
I said neither can I.
Yeah, you're a terrible speller. A vertical stretch of 3. So when I have a vertical stretch, what I like to do is I go from the midline. I like to go up that amount, 1, 2, 3, and down 1, 2, 3. I don't want to know. They're playing video games in the basement, and something exciting must have happened.
Someone is dying.
And now I'm going to remember that when I reflect over the x-axis, the parent function for that goes center, bottom, center, top, center. And that center point is at 2 pi. And because I don't have a period change, so I'm going to go pi over 2, pi, 3 pi over 2, 2 pi, and then the reverse, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Okay, so I'm all set up. I'm ready to start graphing. First thing I'm going to do is I'm going to take these 5 points and drop them. 1, bottom, 2, 3, 4, 5. So there's one period of reflected sine. Then I'm just going to continue the pattern backwards. I hate when I graph right over my scale marks. It's just very aggravating.
Oh, yes. Very aggravating.
There we go. Okay, so now I'm going to do g of x equals 4x minus 1 for one period. And this only says for one period, Miss Weiss. We should probably change that. I don't know if I think you're gone. We're going to go down 1. Down 1. And we have a vertical stretch of 4. Or a dilation. You don't have to say stretch. You can say dilation. So, dot, 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 dot. Here's my new midline. You have to say dot, 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 dot when you make it. Or you can go 1, 2, 3, 4. 1, 2, 3, 4. Now I want to remember that this is a cosine, so a regular cosine function goes top, center, bottom, center, top, and that goes to 2 pi. So let's put down r. So this is going to be pi over 2. That's not even. Oh well, pi, 3 pi over 2, 2 pi. So here we go. Center, midline, center, midline, center. It only says for one period, so I don't have to do more unless I really, really want to.
That's a nice squiggle.
Yeah, it should have been like curvier down here, but I missed. And I didn't want to smudge the ink. All right, Mrs. Weiss loved the beach, so she tracked the height of the tides in feet in Ocean City, Maryland. See, this problem is not accurate because this is not the beach Miss Weiss goes to, but we'll let that one go. The height h of the tide at various times of the day is shown by the graph below. The variable t represents the number of hours since midnight on any given day. Write a function that models the height of the tides as a function of time. So basically, I need to figure out the amplitude, the midline, the period. So,
Looks funny when you write upside down.
well, because that's what makes it confusing is I keep forgetting when I look at my studio screen, it's reversed. But when I look on your Chromebook, because you're watching it, it looks fine.
Mm-hmm.
You shot? Don't even. All right. So I feel like the bottom, hold on, I gotta like take a look at this. I feel like the bottom is at 50. Like I feel like this point is like here at 50. Okay, so I feel like that's the minimum and that's the maximum. So I'm gonna use my formula. So for the midline, I'm gonna do 150 plus 50 over 2. And there are lots of ways to do this. So I subtract, no, I'm finding the midline. I'm going to add them, which is 200 over 2. So shorten off 100. That makes sense.
Mm-hmm.
100 is in the middle. And my amplitude will just, I don't need the formula for that. 100 to 150 is just 50.
Mm-hmm.
The period is obviously 12 because that's the end of the graph and that's the end of the period. So 12 equals 2 pi over b, cross multiply. Divide by 12. Lily, what's 2 divided by 12 reduced?
6. I don't know what reduce means, but
1/6.
Hmm.
Okay. So that's our b value. So here we go. Have all my pieces. Appears to be a cosine function because it's starting at the maximum. So I'm going to write, see, like it's messing me up because I'm trying to turn it right now. I have to turn it the other way. Y equals 50 cosine pi over 6 x plus 100.
I never knew sine.
Oh, I did not use a sine in the first part. Because now it says, if you use a sine in the first part, revise your equation. Okay, but I used a cosine, so now I have to make it a sine. So there's a couple ways to do this. I think the easiest way to do this is probably right here. It's a cosine because it's in the center on its way up. And that appears to be at 9. You could have also done a reflected cosine at 3. Y equals 50 sine pi over 6. X minus 9 plus 100, or y equals negative 50. This tablecloth is very bouncy.
You got one mic.
Oh, all right. All right, that's number 10.
You have a question.
What's the question?
Shouldn't it be HT?
It should. I'm a terrible person.
Uh-huh. Because it's a function of time.
It is a function of time. There you go, Caroline. Got a shout out. This video will live on for eternity.
Huh?
It'll be on forever. I'm never going
Why?
to because I'm too lazy to redo it.
Why
I'm the one take wonder. I do it once.
would you?
If I screw it up, I just fix it and I say, oh crap. That's why these videos are not rated okay for children, because yesterday I swore 2 times. So there's my sign.
Woohoo! Woohoo!
All right. Oh, we're getting there.
You guys have long review packets.
Well, because I make it super long because that way, how long is this? 18 minutes. Holy cow. Tangent. All right. I like graphing tangent because I know that the points are at 0, pi,
You have a boring class.
2 pi. Well, I don't normally go this fast. This is just review day. I've seen some of the work you guys do. It's thrilling.
Thrilling for me, but this is thrilling for you.
All right, you can knock it off now.
Got it.
Thank you. I have asymptotes at pi over 2, at negative pi over 2, curve. Oh, that came out really bad. that curve got hit on a car accident.
Is it supposed to be curved in the middle?
Those look like this. That one looks better.
Mm.
And I could keep going, but I think that's good. Oh, wait, no, it says on the interval 2 pi, so I got to keep going. And I just can't leave that there because it bothers me immensely. I do the other side.
Oh, wow.
Okay. Describe each function as even, odd, or neither. Sine is an odd function because it has y-axis symmetry. Or I'm sorry, it has 180-degree rotational symmetry around the origin. So like this point right here has a buddy right here. Tangent is even because it has y-axis symmetry. My gosh, why can I not read? Cosine is even because it has y-axis symmetry. See what I mean? If I make a mistake, I just keep going. Tangent is odd because it also has 180-degree rotational symmetry around the origin. Describe when the following functions are positive. So,
this is going to be a long video.
Yeah, it is. So you can do this two different ways. You can do it by quadrants or you can do it by intervals. So you can say sine is positive in quadrant 1 and quadrant 2, cosine in quadrant 1. Why did I just make a 2 there? 1 and 4, quadrant 1 and 3. Now, you also could describe that with intervals. So you have to remember, so this is 0, pi over 2, pi, 3 pi over 2. Quadrant 1 is 0 to pi over 2. Quadrant 2 is pi over 2 to pi. You probably could have written that as one interval. So I'm going to write down all the quadrant 1s. Everyone's positive. In quadrant 1. Now, quadrant 4 is going to be 3 pi over 2 to 2 pi. You can go play video games.
I don't want to play video games, Ben.
And then pi. All right. Ooh, shoot. Well, you're supposed to tell me you can't see the bottom.
Can't see the bottom.
Thanks a lot, Describe when the following functions are negative. So this is going to be quadrants 3 and 4. Because take calculus. Quadrants 2 and 3. Quadrants 2 and 4. So quadrants 3 and 4, because they're connected, I can write them with one interval. And I know someone's going to be like, can I just do it one way? Well, you can, but you have to recognize both ways.
I wonder who all the sub people are.
Oh, who knows? So quadrants 2 and 3 are going to be, I just did that backwards. See, like if I screw it up, no, quadrants, I was looking at the wrong one. 3 and 4 are pi to 2 pi. And then this one is pi over 2 to 3 pi over 2. And then 2, pi over 2 to pi. And then 4 is 3 pi over 2 to 2 pi. All right. Name the angles of rotation in radians where the value is equal to 0. So sine is equal to 0 at 0, pi, and 2 pi. And again, I just look at my parent graphs for this. Like 1, 2, 3. So now cosine would be pi over 2, 3 pi over 2. And since we just graphed tangent, we might as well look at it. I mean, damn. All right, so that's going to be 0, pi, and 2 pi also. Okay. Name the angle where the function is undefined. So sine and cosine have none. Tangent is going to be pi over 2, 3 pi over 2, etc. Or we could write like pi over 2 plus pi k, where k is an integer. All right. Describe the period. Sine and cosine have a period of 2 pi. Tangent has a period of pi. 18 might be my favorite question, guys. You know why?
Oh, why?
It's 1. If you know the Pythagorean identity, you know it's 1. Because it's cosine squared of an angle plus sine squared of the same angle. That's the Pythagorean identity. It's just 1. Don't overthink it. Oh! Show that the Pythagorean identity applies for angle beta. So, reminder, it's sine squared theta, beta, plus cosine squared beta equals 1. So sine is 3/5. Cosine is 4/5. Please do not replace these numbers into beta. That is annoying and wrong. So this is going to be 9 over 25 plus square both of them, 16 over 25. Hey, guess what? 9 plus 16. What's 9 plus 16?
I don't know. Well, I mean, I know. I just don't really.
You just don't really want to do it because you're. What are you playing over there?
I'm not.
I'm not going to tell them because that would be embarrassing.
On Google.
Whatever. So there we go. All right, coming to the end. All right, so if cosine theta is 2/5 and theta is in quadrant 4, find sine and tangent. So I'm going to have sine squared theta plus cosine squared theta equals 1. So now I've got sine squared theta plus 4 over 25. And I'm going to write the 1 as 25 over 25. That way when I subtract 4 over 25, I've got sine squared theta equals 21 over 25. Now I'm going to take the square root of both sides, and I've got sine theta equals plus or minus 21 over 25. But I'm in quadrant 4. Sine is negative in quadrant 4. I need to know that. Oh, the audience just left. She had enough. So I guess you guys can comment whatever. Oh, wait, that's 3 of 5. Because I took the square root of 25 and got 5. So there's the sine. The tangent, I need to remember that tangent can be written as sine over cosine. So I'm going to do negative root 21 over 5 divided by 2 over 5. So I'm going to multiply by the reciprocal. And I get tangent is negative square root of 21 over 2. All right. Similar problem, but now I'm in quadrant 3 and I'm given sine. So I'm going to say negative 1/2 squared plus cosine squared equals 1. So I've got 1/4 plus cosine squared equals 1. Cosine squared equals, so if I subtract, make that 4/4, that becomes 3/4. What?
We're not going to Hershey Park.
No, I was so excited to go to Hershey Park.
They canceled all the out-of-state field trips.
Oh, that is so depressing.
It is depressing.
Guys, I'm not going to Hershey Park. I'm so sad.
I'm sad. I was the one who's going to get to go for the first time.
I have to finish. I have 2 more problems,
Okay.
and then we can go cry about not going to Hershey Park.
That's just pathetic.
It's so sad. Guys, this virus is really, like, not cool. We're not going to Hershey Park. I was going to chaperone because I'm already pre-approved. So plus or minus the square root. I totally actually forgot about that. It was a big field trip.
It was.
That's a terrible 3, sorry. So now I have to remember I'm in quadrant 3. And in quadrant 3, cosine is negative. So cosine theta equals negative root 3 over 2. I'm going to do the same trick I did here. I know tangent. Man, I'm running out of space. Tangent of theta is sine. I was excited for that too. I was going to ride all the rides with Mr. Broscoe. Now I can't.
So sad.
I got it, kid. The 2's cancel. The negatives cancel. And I get tangent of beta. Sorry, I switched to theta. It was a habit. My bad. Get it? Beta? My bad. That wasn't funny. It's going to be 1 over root 3. All right, convert from radians to degrees. I'm going to do this work down here because I'm kind of running out of space. So I'm going to do 45 over x equals 180 over pi. I'm going to cross multiply and get 45 pi equals 180x. I'm going to divide by 180. Now, this is where I can't help you. You kind of have to just kind of work on reducing the fraction. If that means you're going to divide these by 5 and then divide them by 3, I'll do it once. So let's say I divide 45 by 5. That would be 9 pi over 18 times 2 is 36. Well, now 9 and 36 are both divisible by 9. So I get pi over 4.
It says they're suspended until further notice.
I know, baby. I'm sorry you're not going to Hershey Park. All right, so for 210, I'm going to say 210 over x equals 180 over pi. 210 pi equals 180x. And the zeros cancel. I'm going to divide these both by 3, and I'm going to get 7 pi over 6 for 210. So for this one, I'm going to say 2 pi over 3 over x equals pi over 180. So I'm doing radians over degrees equals radians over degrees. So 2 pi over 3 times 180 equals. Now we kill the pies. I'm just going to divide 180 by 3 because that's just faster. And that gives me 30. No, 60, duh. 2 times 60 is going to be 120. Okay, so see how this last one is negative? I'm not even going to worry about the negative. I know my answer is going to be negative. Boom. I'll write it down. And I'll just worry about the pi over 6. Pi over 6, that's a terrible 6, over x equals pi over 180. And I've got 180 pi over 6 equals x pi. These cancel. 180 divided by 6. So this is just going to be negative 30 degrees. Boom. And thanks to the power of YouTube Live, I don't even have to upload this off my phone. It's already there. Bye.
See you later.
See you later.
I definitely do.